with tangent. Hopefully you know this one, right? Tangent of some theta equals the square root of 3, right? So I'm going to do tangent to the negative first power of the square root of 3 equals x, right? And when you look at this, all right, you're thinking about your table, right? And I know that if you look at the table, right, we've got the tangent of pi over 3 is equal to the square root of 3. So my reference angle is going to be pi over 3. So I'm looking where tangent is positive. Definitely positive in the first quadrant. We know that one is pi over 3. All right. But in terms of the other one that we have, all right, tangent is also positive in the third quadrant. So that's pi plus that reference angle of pi over 3. So one of my answers is that actual reference angle. And the other one is going to be pi plus pi over 3. So getting a common denominator is 3 pi over 3 plus pi over 3, which is 4 pi over 3. All right. Now, one thing that I do want to mention, it does say all solutions. So I was really kind of just solving this as if it said between 0 and 2 pi. All right. But if you want to do the all solutions, what you're going to end up doing is writing theta equals that pi over 3. And if you look, this might be a little difficult to explain. I'll try my best. If you look at going from pi over 3 to our other angle we found, 4 pi over 3, that's actually going to be just adding pi. So we're going to do plus or minus pi times k. So it's a little different. You may be wondering, wait, Mr. Render, didn't you say 2 pi k? I did, but that was for sine and cosine. And for tangent, right, if you think we're looking at tangent, the period for tangent is pi. So that is one of those things that's a little bit different for tangent. All right, let's look at another one. Again, we've got all solutions, but it does give us a kind of in between certain values. So that's nice. So I don't need to worry about doing the plus or minus k or pi k. So let's distribute the 2. We get 2 times the tangent of x plus 6 equals 5 plus the tangent of x. I'm going to move the tangent of x over and subtract 2 tangent of x minus 1 tangent of x to get tangent of x. Then I'm going to move the 6 over with subtraction. So 5 minus 6 is negative 1. All right? So now I'm going to essentially tell my brain, okay, tangent to the negative first power of, notice I did positive 1 here to find our reference angle, because in my table of special angles, I do know that the tangent of pi over 4 is positive 1. So I'm looking for, in my quadrants, where tangent is going to be negative, right? That's right here. So I'm thinking, where is tangent negative? It's negative in the second quadrant and in the fourth quadrant. So it's going to do pi. We're going to back up the reference angle. And to find my fourth quadrant is 2 pi, but you back up the reference angle. So those are my two answers. Pi minus pi over 4 and 2 pi minus pi over 4. Get a common denominator. You get 3 pi over 4, and this is going to be 7 pi over 4. So those are my two solutions for those. Okay, let's do some with quadratics. I know you guys love factoring, so we're going to do some with some factoring, and even going to use an identity from earlier in the unit to do this first one. And don't worry, we've only got 3 left, so we're almost done. Okay, so one thing I noticed is I've got sine squared and cosine. I don't want to deal with factoring with 2 different trig functions, so I'm going to use one of my Pythagorean identities. Sine squared theta, or x, plus cosine squared x equals 1. And if I isolate this for sine squared, by moving the cosine squared over, I get sine squared x equals 1 minus cosine squared x. So I'm going to take this sine squared right here in the problem, and I'm going to replace it with 1 minus cosine squared theta. Okay, so that's kind of the first thing that I'm trying to do, is just deal with only cosines. So I have 1 minus cosine squared theta equals 2 cosine theta plus 2. You may be asking, Mr. Frederick, how did you know to isolate for that one as opposed to isolate for cosine squared? Well, if you isolate for cosine squared, you're going to end, or excuse me, if you look here, we don't have cosine squared. So that means I need to deal with the terms in terms of cosine, the problem in terms of cosine. So that's why I knew to change sine squared to be with cosine squared, because I already have a cosine. So that's kind of what drove me to do that decision. Let's move everything to the other side. That's going to be a positive cosine squared theta plus 2 cosine theta. And then when you move the 1 over with subtraction, 2 minus 1 is 1. So if we factor this, right, think about your days of factoring. So instead of x and x, it's just cosine of theta and cosine of theta. Factors of 1 that add to 2 is plus 1 and plus 1. So you actually could write this as cosine of theta plus 1, all of that squared. All right. So since they're the same, all I'm really going to do is just solve for one of them. All right, because I only have one double root. So you move that over. All right, and again, because this doesn't say tangent, I know this is going to be quadrantals again. I think this might be exactly the same one we had at the beginning. All right, so if I think, trying to tell my brain, okay, I know the cosine of some angle equals -1. What is that angle? And you go back to your quadrantals right here. And we're looking where cosine is a negative. So it's actually exactly the same value as this one up here. It's going to be pi. All right, so that is our answer for that first one. Okay, let's do these last two. All right, so it says we're looking for values of theta between 0 and 2 pi. I don't have a third term, I don't have a constant, so I'm not going to do my 2 parentheses like that. What I'm going to do instead is just factor out a sine of theta. When I do that, I get 2 sine of theta plus 1 equals 0. So I actually have to set up 2 of these equations equal to 0. I'm hopeful that you'll see on this first one that this one is really essentially asking about a quadrantal again. Could actually be quadrantals, plural. All right, sine of 0 is 0. And also, if you look up here, it doesn't say or equal to 2 pi, so I'm not going to put 2 pi. But with the quadrantals, the y value in the ordered pair at pi, I'll just show you since we just looked at it. Right, if you look here, the y value in the order pair for pi, which is sine, is 0. So pi is also going to be a solution for this one. And I would have put 2 pi if this would have had or equal to underneath the symbol, but it did not. So those are the 2 solutions for that one. Let's isolate this sine of theta. That's -1. Divide by 2 to get -1/2. I think we've done this a couple of times. So sine to the negative first power. Notice I'm doing +1/2 to find my reference angle. Reference angle is going to be pi over 6. And I'm looking for in my quadrants where is sine equal to negative, which is going to be the third quadrant and the fourth quadrant. So again, that's pi plus the reference angle and 2 pi minus the reference angle for my 2 answers here. So pi plus pi over 6 and 2 pi minus pi over 6. So 7 pi over 6 and 11 pi over 6. Those are the 2 solutions for that one. So you actually end up having 4 different answers for this equation. You've got these 2 thetas, and you've got these 2 down here. Okay? All right, one more, and then we'll be done. All right, so this last one is cosine. It's actually exactly the same as the one to the left of it. The only difference is that it's cosine. So let's factor out the cosine of theta cosine of theta times 2 cosine of theta plus 1. So just like before, let's set them equal to each other. So cosine of theta equals 0. 2 cosine theta plus 1 equals 0. So this one is going to be quadrantals. Let me show you what my brain's thinking. Cosine to the negative first power of 0 equals theta. So let's go to our quadrantals. And where are the x values going to be 0? There we go. So if I zoom in, the x values are 0 at pi over 2 and at 3 pi over 2. So that's what I'm going to put for my answers here. I'm going to put pi over 2 and 3 pi over 2. It doesn't say what I should use, so I'm just going to do the same thing I did on the last one, which is between 0 and 2 pi. So pi over 2 and 3 pi over 2. All right, and this one, if I set cosine, get it equal to the other side, or isolate cosine, I should say, move that over, get -1, divide by 2. All right, so here we go. So cosine to the negative first power of 1/2 equals our reference angle. So this is going to be pi over 3. And I'm looking to see where is cosine, right? Where is cosine? Negative. Cosine is negative in the second quadrant and in the third quadrant. So that's going to be pi minus the reference angle and pi plus the reference angle for my 2 thetas. So pi minus pi over 3. And then my last one is pi plus pi over 3. So that's going to be 2 pi over 3 and 4 pi over 3. And that is it. That is how you do these problems. All right. Again, it's going to take some time to practice. Got lots of opportunities to practice with an IXO link and 2 Delta Math links. All right. So don't forget, put in the time to make sure you know how to solve these trigonometric equations. Good luck.